Alright, hello, good day, good night, whatever time it is, it's time to roll. Let's get the show on the road. In this video, continuing in our series on algebra, we're going to look at some special expansions along the topic of algebraic expansion. Right? There are a few expansions that it will be helpful if you know these off the top of your head. So what we're going to do is derive them so that if need be you could actually work them out on your own in the exam. But if you know it at the tip of your fingers, it makes life a lot easier, especially in the multiple choice part of the exam. So first thing we're going to look at is the expansion of, let us say, a plus b all to b squared. A plus b all to b squared is the same thing as a plus b multiplied by a plus b. Alright? If 5 squared is 5 by 5, and 10 squared is 10 by 10, and 2 squared is 2 by 2, and minus 6 squared is minus 6 by minus 6, and minus 7 squared is minus 7 by minus 7, and minus 8 squared is minus 8 by minus 8. Then a plus b, all in brackets squared, could only be a plus b multiplied by a plus b. Alright? And we expand it. A plus b into a plus b is equal to a by a is a squared, a by b is ab, plus b by a is plus ba, plus b by b is b squared. Alright? Now a by b is the same thing as b by a, right? 2 by 3 is 6, 3 by 2 is 6. 4 by 5 is 20, 5 by 4 is 20. So in general, AB is the same thing as BA. Alright? So if AB is the same as BA, we can write this over as A squared plus AB plus AB plus B squared, which is equal to A squared plus 2AB plus B squared. Alright? So keep that in mind. You have it here in video. You have the option to rewind to go it over if you need to. We're going to clear the board here and go into the next special expansion. Alright, so a while ago we had a plus b all to b squared. So this time we have a minus b all to b squared. Alright, which, following the logic that we had established a while ago, will be equal to a minus b into a minus b. Alright, which is, right, and we write it out here now, a minus b into a minus b is equal to a by a is a squared. A plus a by minus b is minus ab. Note very carefully. Alright, minus b by a is minus ba, minus b by plus a is minus ba, and minus b by minus b is plus b squared. Alright, so that a squared minus ab by minus ba. Now we had established in the last one that we just did that a multiplied by b is the same thing as b multiplied by a. Alright, so if ab and ba is the same, we can write this over as a squared minus ab minus ab plus b squared, which is the same thing as a squared minus 2ab plus b squared. Alright, you want to know why minus ab is the same as minus ba? Because, alright, minus ab is the same thing as minus 1 by a by b, and minus ba is the same thing as minus 1 by b by A. Alright? This minus 1 here is the same as this minus 1 here. And if we establish that AB is the same as BA, then minus 1 by A by B, it will be the same as minus 1 by B by A. Right? So therefore minus AB will be the same as minus BA. So don't be confused by the minus signs. Right? Yes. We can understand that AB is the same thing as BA. We don't have any minus signs to contend with. Alright? If we take the minus sign outside, right, I'm going to write this over now. Okay, I'm leaving that there. So what I'm going to do is write this over. I have to clear the board while we're talking here. Right? If I write this as minus AB in brackets, and I write this as minus BA by brackets, it's just a minus sign multiplied by BA, a minus sign multiplied by AB. And if we establish that AB is the same as BA, then we can write minus BA as minus AB, which is what we did to move from here to here. Alright? So writing this over as minus AB will allow us now to say that minus AB is minus 2AB. Remember your number sign, remember your directed numbers. So that A minus B squared, A minus B into A minus B is equal to A squared minus 2AB plus B squared. So again, you have it on video. You can rewind if you need to. You're going to clear the board now and go through another special expansion. Alright, so we had A plus B squared, which was A plus B by A plus B. We had A minus B squared, which was A minus B by A plus B. How about A minus B by A plus B? Or A plus B by A minus B. It doesn't make any difference which one you do first. My personal preference is to put the minus first. So I like to start by saying A minus B into A plus B. That is just my preference. It doesn't have to be yours. Right? Some people prefer to write the plus first, and that is perfectly fine. Alright? So A minus B into A plus B is equal to A by A is A squared, A by B is plus AB, alright, minus B by A is minus BA, and minus B by plus B is minus B squared. Alright? Now we established that AB is the same as BA. So we can write this over as A squared plus AB minus AB minus B squared plus AB, and the minus AB will cancel out to give us A squared minus B squared, and that is the answer. So therefore, A minus B into A plus B is equal to A squared minus B squared. This too is a special expansion, and as a separate exercise I will leave it up to you to multiply A plus B into A minus B, where we're just writing this over with the positive sign in front. I'll leave you now to verify that that is actually equal to A squared minus B squared as well. Alright? So I want you to prove on your own that it doesn't matter whether you put the plus sign first or the minus sign first when you're writing the product of A minus B and A plus B. Right? If you're having any difficulty here, you know how to reach me. Alright? You could ask for help. You might have somebody else who might help you, or you could check me and I'll go through it. Right? That is another opportunity for you to just reinforce the multiplication, to reinforce in your own mind that A plus B multiplied by A minus B is the same thing as A minus B into A plus B. So, you have that there on the board, rewind if need be. Now we're going to summarize all three together. Alright, so we're going to summarize the three expansions that we just went through. The first one was that A plus B squared, alright, equal to a squared plus 2ab plus b squared. The second one was that a minus b squared is equal to a squared minus 2ab plus b squared. Alright? Note well, the only difference between these two, starting with the fact that they have a plus b versus a minus b here, is that instead of plus 2ab here, you have minus 2ab here. So in other words, in this one, the only time we have a minus sign is minus 2ab. We don't have minus b squared. So this is not a squared minus 2ab minus b squared, which is an easy mistake to make. Reason being that when we multiplied it out as we did earlier in the video, and you could double check it by rewinding it if you need to, we had that minus b by minus b is plus b squared. Alright? And then the very last one we had was that a minus b into a plus b, right, is equal to a squared minus b squared. Right? Now this last one here is what we refer to as the difference of two squares. Alright? The difference of two squares. It is very important to know that one because it will show up in your factorization, which we'll come to a little later. Alright? So it is, you have to know the expansion. Right? These will show up when you're expanding stuff. A plus b to the squared, a minus b to the squared. Those will also show up in your multiple choice. Right? And knowing that is one of the things that will save you time in a multiple choice questions. Alright? So pay attention to the last one. A minus b into a plus b, the difference of two squares. A minus b into a plus b is a squared minus b squared. A plus b into a minus b, same thing, which you would have gone through prior to this point in this video, is a squared minus b squared. In your factorization, they will give you a squared minus b squared until you factorize, which working backwards will give you a minus b into a plus b. But we will come to that soon enough. Alright? So be aware of these three special expansions. Hold on to them. You will have opportunities to practice. In fact, let me recommend some exercises here now. From this same sheet, right? So, let us go through some examples. I will go through the examples. So, to go through these expansions, I would want you to do exercise 13F and 13G. Alright? So what I'm going to do now is to just go through the examples for 13F and 13G, just to show you how to get what I get. And after that, the floor is all yours in terms of doing the exercises. Alright, so you have x plus 5 all to be squared. Alright? X plus 5 to be squared is equal to x squared. Right? We know that's the first step. Plus 2. Remember, it's a plus b to b squared is a squared plus 2ab plus b squared. So that x plus 5 squared will be x squared plus 2 by x by 5 plus 5 squared, which will be x squared. 2 by 5 is 10 plus 10x plus 25. Alright? Next example. Expand 2x plus 3y. 2x plus 3y squared will be equal to 2x, all in brackets, squared. Notice the brackets, plus 2 by 2x by 3y. So in other words, the first term squared plus 2 by the first term by the second term plus 3y by itself now, all to be squared. Alright? 2x squared is 4x squared. 2 by 2x by 3y. 2x by 3y is 6xy. 6xy by 2 is 12xy. And 3y squared is 9y squared. Right? That is that example there. So we're going to clear some space on the board now and do the third example. Alright, so let me just clear this. Save some time here. Alright. So we clear this now and we're going on. So we now have x minus 5 squared. So we had x plus 5 squared on top, now we have x plus 5 minus 5 squared. So x minus 5 squared is equal to x squared. Now we have minus 2 by x by 5 plus 5 squared, which is equal to x squared minus 2 by 5 by x is minus 10x plus 25. Right. So note the difference between x plus 5 to be squared and x minus 5 to be squared. Alright. And then we have another one here, right, of similar dimensions. We have 2x minus 7 to be squared, 2x minus 7 to be squared is equal to 2x squared whole 2x squared minus 2 by 2x by 7 plus 7 squared. Resist the temptation to put minus here, right? That you will solve by practice. So 2x squared will be 4x squared minus 2 by 2x by 7. 2x by 7 is 14x. 14x by 2 is minus 28x. 7 squared is still 49. Alright? So you're seeing how we go about working it. You're hearing me explain it as you work it out. So hopefully between that and actually having it here, that will put you in a position now to actually attempt the exercises. Alright? Right, and then we have another one here, 7a minus 4b, or to be squared. This is the one that I like because it gives you a little more difficulty now in these questions. So we now have 7a minus 4b, or to be squared, which is equal to, pay attention now, 7a or to be squared minus 2 by 7a by 4b plus 4b in brackets, all to be squared. Alright? So 7 by a squared, 7a all to be squared will be 49a squared. Minus 2 by 7a by 4b. 7a by 4b is 7 4 is 28. A by b is ab. So that will be 28ab by 2. 28 by 2 is 56. Alright? So that will be 49a squared minus 56ab plus 4b squared is 16b squared. And that is it. That is it. Alright? So you have the foundations there to run through some questions in 13F. Again, if after X number of questions you feel that you have the hang of it, that is fine. there will be more than sufficient opportunity to practice these things under exam conditions. And as we go along, that will give you a further opportunity now to fix it and to get it right. Alright, so that is 13F. I want to go through 13G as well, so I'll also go through the examples in 13G. So that is also something for you to do, and that more or less will be the end of this particular document here in terms of doing the questions. Alright, so just bear with me a little bit again. 13G. Alright, so examples. Expand a plus 2 into a minus 2 and 2x plus 3 into 2x minus 3. So in this book, they clearly favor having the positive one first, and that is fine. What I will do, I will work one with the positive first and I will work the other one with the negative first, just to demonstrate that you're getting the same answer that you will get from with what they have here. Alright, so we have to start a plus 2 into a minus 2. Right, now one of the key factors when you're dealing with difference of two squares is simple observation. Right, I tell people all the time, observation is the first law of the mathematical jungle. Right? Very often, simple observation will make your life a lot easier. Alright? It will clue you into something that will allow you to work something faster. It will allow you to get to the solution faster than if you don't notice it. So for example, in this question here, we could do the long way or the short way. The long way would be to expand everything out. And if we do that, we'll get a by a squared is a squared, right? A by minus 2a is minus 2a, plus 2 by a is plus 2a, and plus 2 by minus 2 is minus 4, right? And then we say a squared minus 2a plus 2a is 0, minus 4. We could do that and get it correct. But if you would have recognized that this is a plus 2 multiplied by a minus 2, in other words, the difference of two squares, and knowing that a plus b into a minus b is simply a squared minus b squared, then from here you can go straight into the next line and say that a plus 2 into a minus 2 is simply a squared minus 2 squared, which 2 squared we all know as being equal to 4. And you solve the question like that, right? So the difference of two squares, whether you're expanding or whether you're factorizing, is one area where the examiners wouldn't be expecting an essay. They wouldn't be expecting a dissertation. You don't have to write 4 to 5 to 6 lines of working to do the difference of two squares. All you have to do is to show that you recognize the difference of two squares. And once you recognize the difference of two squares, it's just one line, maybe 2 lines max, to just write the answer and proceed. Alright, so we go with the second example now. So we're clearing the board again. Alright. So they have it written as 2x plus 3 into 2x minus 3. We're on page 171 here now. Alright. 2x plus 3 into 2x minus 3. I will write it over as 2x minus 3 into 2x plus 3. Alright? And again, difference of two squares. Right? You have a plus sign and you have a minus sign. Same entities. 2x plus 3, 2x minus 3. This will simply be, watch it now, next line. 2x squared minus 3 squared. 2x squared is equal to 4x squared minus 9. End of discussion. No such a long talk there. Alright? The next one we have, which clearing the board again. Clearing the board again, we have here 3x plus 2y to 3x minus 2y. Alright, 3x plus 2y into 3x minus 2y. Again, difference of two squares. 3x plus 2y into 3x minus 2y. Alright, you would have as equal to 3x in brackets squared minus 2y in brackets all to be squared. 3x squared is still 9x squared, and 2y squared is still 4y squared. End of this discussion. Alright, story done. So, with that in mind, you are now in a position to do 13G as well as 13F before it. And that, ladies and gentlemen, is the end of the matter where this particular chapter is concerned. Right? I also included the answers at the back of the document. So everything is in one document. You have it there. Use it. Alright? Don't feel that looking at the answers is something wrong. Sometimes you'll want to prepare the answer before you finish the question. Sometimes you'll want to do the question first and then look at the answer. So either way it will work out. The bottom line is that learning will take place so that when you find yourself in the exam under pressure and you see 2x minus 3 into 2x plus 3, you know immediately that is 2x all to be squared minus 3 to be squared, which is 4x squared minus 9. And you'll be able to work out any other variation of the difference of two squares or the expansion of a plus b minus a plus b to be squared or a minus b to be squared. So that more or less covers the topic of algebraic products. I wanted to take these things seriously because from here the next step is factorization, which is the reverse of expansions. Alright? So we have to get through expansions first, understand expansions, and that now will lay the platform for factorization, which, as you would know by now, is one of the most important topics in algebra. Cool? So, hit the ground running.